Hi, in this video we are going to talk about the first implementation of the list interface. So we are going to talk about array lists in the main. The underlying data structure is an array, so an array stores the values in the background, and an array is basically like this. I'm sure that you are familiar with it. You can create a string array, you can create two-dimensional arrays and whatsoever. We have to specify that how many items we are going to store in a one-dimensional array, for example. Why do we like array lists? Basically because of random access. Random access is very fast. It is basically accessing items by the index. So for example, we get the item with the 0 index. Indices starts at 0 in Java. So that's why the first item is going to be the item with the index 0. It is roughly equivalent to vector, but array lists are not synchronized. So vectors are synchronized, but array lists are not synchronized. This is what we have been discussing, that we have an iterable interface, a collection interface, the list interface, and the array list, the linked list, the vector are the concrete implementations of this given list interface. So the random access is very fast. But basically all other operations runs in ordo and linear time complexity. And if we want to remove an item, then this operation is not going to be so efficient in array lists because we have to shift each item in our list. So it's going to have ordo and linear time complexity, which is not that bad. If we want to remove several items from a given list, then we should use linked lists. Anyways, if we know the concrete indices and we would like to use random access, then we should stick to array lists. Okay, we have an important parameter, the so-called capacity. It is a parameter we can define when we instantiate an array list, for example, like this. Because let's suppose the situation when we know that we will store 5 million items in a list. We have to define this capacity because this may reduce the amount of incremental reallocation. Because at the beginning we just allocate memory for 10 items. Then we come to the conclusion that it's not going to be enough. We create a bigger array and we have to copy the items from the old array to the new array. Then that new array is going to be small, so we have to create another array and we have to copy the items again. So that's why if we do not specify the capacity when we know that we will store lots of items, then it's not going to be that efficient. We have to define the capacity, and in this case the underlying array is going to be defined something like this with 5 million items. Okay. So let's see the concrete implementation. We have the list of, for example, we would like to store strings, and I'm going to have the name list, and we have to instantiate this new array list. Don't instantiate our class because this has the same name as the java.util.arraylist. So let's instantiate java.util.arraylists. If we want to add some items, for example, I add Adam, I'm going to add Joe and Kevin, for example. And I would like to iterate through. We don't have to use iterator because we can use for each loop. Something like this, I'm going to print out the S. If I save it and run the code, of course Adam, Joe and Kevin will be printed out. What's very important to see that if we call this add method, then these names are going to be added at the end of the list, as you can see. So Adam is the first one, then Joe and Kevin. Because we have added Kevin the last time, that's why it's going to be the last item in the list. What if we would like to remove something? Okay, it's not going to be that efficient when we use array lists, but we can remove, for example, the first item. Indices starts at 0, so that's why the first item is going to be the 0 index. Of course, we have managed to get rid of Adam from the list. What is the random access? We have been talking about it. If we would like to access items and we know the index of that given item, we can get it with the help of this get method. I would like to get, for example, the item with index 1. Then it's going to return Joe. Of course, after that we iterate through and print out all the names, but as you can see, we have managed to get Joe. And this is what I have been talking about, that this is the random access. We access items by the index and it is very, very fast. This is why we like array lists. If we want to get several items from a list in a given application and we know for certain that the indices are going to be defined, then basically we have to use array lists, because if we know the index, then we can get the given items with the help of the indices very, very fast. So we are able to get the items, we are able to remove the items, we are able to print out, for example, the size of the list. For example, list.size, it's going to be print out 3. We can check whether it is empty or not. We have the isEmpty method. Of course, the list is not empty, so it's going to return with false. And what's very important, what we have been discussing in a theoretical section, that we can call the toArray method, and it's going to convert this array list to a one-dimensional array. Okay, we have to, this is the hash code, so it's not that talkative. For example, I'm going to create an array and it's going to return a one-dimensional array of object. So something like this, for example, array. And we just have to iterate through this array. For example, I'm not going to cause the values, I'm going to iterate through as an object and I'm going to print out the S, then it's going to return the same values. So Adam, Joe and Kevin. Okay, there's a new line character. As you can see, Adam, Joe and Kevin. So basically these are the most important features as far as array lists are concerned. It is the implementation of lists. We are able to add some items, we are able to remove some items, we are able to get the size of the list, we are able to convert it to an array, and we are able to define the capacity. So for example, this is the capacity, and we tell Java that let's create an array list where the underlying array can contain up to 10 items. It's going to work just fine. And what's very important to know, that we like array lists because of random access. If we know the index, we are able to get the items extremely fast. But we don't like to remove items from a list. Why? Let's suppose the fact that we would like to remove, for example, list.remove the first item. We have lots of items inserted into the list, for example, several times Kevin. If we get rid of this Adam, then Joe is going to be put into the first slot because we have get rid of Adam. Then Kevin is going to be shifted up. Then this Kevin is going to be shifted to this position, this Kevin to this position, this Kevin to this position, and so on. So there's going to be lots of shifts. This is why linked lists in this case are going to be much better. So in the next video we are going to talk about linked lists. Thanks for watching.